Hey, have you ever really looked at a flower and noticed how the petals spiral out? Or how about that catchy part of a song that just gets stuck in your head? Well, that's not an accident. Our world is absolutely built on patterns. So today, we're going to crack the code, look at these hidden rules, and see how they create this amazing mathematical language of sequences. Let's jump in and learn to speak the secret language of the universe.
All right, first things first. Let's talk about spotting these patterns. You know, our brains are basically hardwired to be pattern detectives. We're constantly searching for order and logic in everything, whether it's the rhythm in a piece of music, the design on a building, or even just the way leaves grow on a tree.
So just for a second, think about your day. Where do you see them? Maybe it's the tiles on the kitchen floor, or the predictable cycle of traffic lights, the seasons changing throughout the year. I'm telling you, once you start looking, you'll see them absolutely everywhere. And that really gets us to the heart of it. In math, these patterns aren't just pretty to look at. They are a genuine language. And if we can learn to understand that language, we can describe, we can predict, and we can even influence the world around us. That's pretty powerful stuff.
Okay, so if we're going to learn this new language, we've got to know the grammar, right? And that starts with two really important words that you're going to hear a lot: patterns and sequences.
Let's break this down, because the difference is subtle but super important. A pattern, that's the rule itself. It's the how-to guide. Think of it like a recipe. Now, a sequence is what you actually get when you follow that recipe. It's the finished, ordered list of things. So really simple. The pattern is the rule, and the sequence is the result.
You know, the best way to really get this is to just see it in action. So let's take a quick walk through a little gallery of some famous number patterns. I bet you've seen some of these before.
Okay, so check this out. Look at these two sequences here. The first one kicks off at 4, then goes to 14, then 24. You see it, right? The pattern is just add 10. Simple. And the second one starts at 9, but the pattern is exactly the same. Add 10. It's a perfect example of how one simple rule can create two completely different but totally predictable sequences.
Now for something that looks a lot more complicated, but is built on a rule that's just as simple. This is Pascal's triangle. The pattern here is just beautiful. You've got ones all along the outside, and every other number is just the sum of the two numbers right above it. See that? 1 plus 2 gives you 3. A simple little addition rule creates this amazing complex mathematical structure.
And of course, we have to talk about the superstar of sequences, Fibonacci. The rule couldn't be easier. You just add the last two numbers to get the next one. So 1 and 1 make 2. Then 1 and 2 make 3. Then 2 and 3 make 5. And it just keeps going. And the craziest part, this isn't just some math exercise. This exact sequence shows up all over nature, from pine cones to seashells.
So spotting patterns is cool, but what if we want to describe them in a really powerful way? What if we wanted to find the 100th number in a sequence, but without having to write out all 100 numbers? Well, for that, we need to bring in the ultimate power tool, algebra.
Now, before we really dive into the algebra, we need one more piece of lingo. It's the word term. A term is just any single number or item in our sequence. And the crucial thing here is that every term has a specific position, kind of like houses on a street, all having their own address.
So what we do is we label them. The first term is T1, the second is T2, the third is T3, and so on. In this example from our source, T1 is -9, T2 is -11. This simple little numbering system, this is the key that's going to unlock everything for us. Which leads us right to the big question. I mean, listing out numbers is fine if the sequence is short, but it's not very efficient, is it? So how can we capture the rule itself in a way that lets us find any term we want, no matter how far down the line?
And here is how we make that incredible leap. Step 1, we look at our sequence. We've got 3, 6, 9, 12. Okay. Step 2, we spot the pattern. We're just adding 3 every time, right? It's just the 3 times table. And finally, step 3, we translate that rule into algebra. The expression just becomes 3n, where n stands for the position of the term you're looking for.
And 3n is so much more powerful than just writing out the numbers. It's a recipe. If you want to find the 50th term in this sequence, you don't write out 50 numbers. You just plug in 50 for n. 3 times 50 is 150. Boom, you're done. That is the incredible power of algebra. Wow, so we've gone on a bit of a journey here, right? From just noticing general patterns in the world
to defining them with numbers, and now, finally, to being able to describe and predict them with algebra. Let's bring it all home.
So let's just boil it all down. Patterns, they're the rules behind everything. Sequences, they're the ordered lists that those rules create. And yeah, we can describe them with words like add 3, but the real magic happens when we use algebra to truly master them.
So, as you go through the rest of your day, keep your eyes open. Math isn't locked away in some textbook. It's in the rhythm of music, the structure of a building. It is all around you, just waiting for you to notice. So the only question left is, what's the next pattern you're going to discover?